Hi teachers, in this set of videos we're going to look at Unit 5, Introduction to Fractions. So you'll spend a week on this unit and it may seem like a lot of time just to introduce the concept of fraction, but as you know, students have a lot of difficulty with fractions and we really want to establish ways of thinking about fraction as number. And there's many ways to do this, so we want to start with this and really spend some time delving deep into it. It will really make your follow-up work on operations with fractions go more smoothly. So let's look at 5.1, which is entitled, What is a Fraction? Okay. So in this section, first we start by looking at language of fractions and looking at it in a few different ways. So again, we're continually speaking in this type of language when we talk about fractions, and students need to connect this language to the ideas. So notice we have divided by, out of, ratio of, per, for, every. So this will start to give them an idea of how we would represent these phrases or language in terms of fractions and fraction word names. Okay. With fraction word names, you may have noticed in the past, so this would be 20 divided by 6 is 20/6, and that's always hard for me to say, to really get that "the" in there, which is probably why they make a lot of errors. So 26, and they kind of hear 6 instead of 6, so that word is helping them connect the idea to a fraction instead of just the number in the denominator. Okay. Next we have different types of ways of conceiving of fractions. So there's lots of ways to think about a fraction and ways that we use them in context. And we typically have a robust understanding of fractions, so when we look at fractions in a different context, we've had the experience so we can just understand the meaning. But these are all different types that students need to be aware of, and it's important to express them explicitly so they don't have to kind of figure that out for themselves. So they still will have to make sense of it on their own, but to say a fraction isn't just one type of meaning, and we'll be looking at different representations and context to help them understand these different types of meanings. So the first one, division. Students are usually pretty solid with division, but it's important they know. So if you had 5/7 or 5/7, that's equivalent to 5 divided by 7. And they usually know this because when they see a fraction, they want to put it in their calculator, make it a decimal, so it's no longer a fraction. Okay. And this is a concept we looked at when we talked about division. We did this with whole numbers, like 12/3 is equivalent to 12 divided by 3, which is 4. Okay, so they've seen this idea before. We also looked at fractions with remainders, or division with remainders. So this, in the past, we would say this was 4 remainder 1. Okay, but we will connect this to the idea of mixed numbers. But for now, we just want to show them, hey, you've seen fractions already. One way to think about it is division. Now the next way is, or another way, is the part-whole model. So you have a part in the numerator and a whole in the denominator. So say a student gets 7 questions correct out of 10 total questions. Okay. And whenever possible, and sometimes I don't do this either because it's a lot to write, to always write these types of units, but you want to use descriptors, especially in a context or an application problem, to describe what the number is representing. So this should officially be 7 correct questions over 10 total questions. I shortened it a little bit. But you want to use units as descriptors so they can connect the ideas. So frequently in elementary school, students are introduced to this part-whole model, and they need to have other models of fractions as well. This one can be problematic because if they think of a part and a whole, the part is always smaller than the whole. Okay, so you can't get 12 correct if there's 10 questions. So we do want them to see this idea, but we also want them to know that a fraction need not be a smaller number over a larger number. And typically in our everyday language, you'll hear people say things, oh, it was just a fraction of the cost, meaning that it was less than 100% or less than the amount of the cost, something small, okay, where fractions don't necessarily need to be that. So the part-whole model is very useful. We use it a lot, but it can't be their only understanding. Now we have a part-to-part model. So maybe we want to do 7 correct questions to 3, I'll write wrong because it's shorter than incorrect. Okay. And notice we could also write a part-to-part ratio in the other direction, 3 wrong to 7 correct. So these are representing multiplicative comparisons, and in Unit 10 we're really going to delve deep into this type of ratio to solve proportional problems. We won't be solving proportions using cross-multiplying. We're going to be solving them through reasoning with ratios. So we're introducing this idea here, but it's really going to come into play a lot later, so it's good for them to have an introduction. And finally, rate. So notice here the difference between a ratio and a rate. So a rate is a type of ratio, but the types of units in the numerator and denominator are different. So here, notice we labeled them wrong and correct, correct and wrong, correct and total. Okay. So those seem like different units, but it's really referring to the questions or the number of questions. So here we would call this a ratio because it's referring to types of questions. An example of a rate, miles and hours, is a great one. So maybe 20 miles in 4 hours. Okay, and it's not just that they're different types of units. Notice they're measuring different types of things. So miles is measuring distance, hours is measuring time. Okay. Rates are notoriously difficult for students. They're usually good with miles per hour because they have experience driving. Okay, at least our students do. But you need to think, we're starting with a unit, miles, which represents distance. We're dividing it by a unit that represents time. But the unit of our answer, miles per hour, that's representing speed or velocity. So through this transformation, we're actually developing a different type of unit. It's measuring not time, not hours, but time in relation to hours. Or, sorry, not distance, not time, but distance in relation to time, excuse me, which is a different understanding. So this happens also, you could think of with inversely proportional ideas. If you have a job that's going to take 16 hours, you can have maybe, 4 is not a factor, 3 is not a factor, 3 men working 4 hours each would be, we might say, 16 man hours. Okay. We also could have 1 man working for 16 hours. So again, this is an inversely proportional relationship, but I'm just trying to draw your attention to how when we multiply or divide different types of units, our answer is a brand new type of unit. Whereas if we did 16 hours minus 4 hours with addition and subtraction, our unit does not change. This would be, I almost said 4 hours, 12 hours. Okay. Or if we have a ratio with the same type of units, so if we have 5 miles over 2 miles, we could keep the units in there, but officially they cancel out, and we would say our answer is dimensionless, meaning it doesn't really have a unit, it's a scalar multiple. Okay. So again, these aren't things that you need to, scalar multiple and the man hours and all that you need to discuss with your students. But when you're working with them, you want to see if they're having trouble with these different types of understanding of units, and draw some things like speed being different from distance and time to their attention. Okay. So in these examples, you can go through different types of measures. And now the importance of the unit. So we talked about units in terms of labeling units. Okay? But a really important idea of units when we're talking about fractions is what the unit is, what is representing 1 in this scenario. Okay? So you could think if you're talking about cookies, you could say 5 cookies, and cookie is the unit that represents 1 cookie. If you're talking about 5 bags of cookies, then a bag of cookies is your unit of measure. A bag of cookies may have 15 cookies in it, but you're changing your unit. And we do this in fractions all the time, and students have difficulty with this because we're not always, and problems aren't always explicit about what is representing 1. So when we have them in abstract form, this isn't really a problem, but when we use pictures, which are meant to help them and guide them in their understanding, if we don't tell them what represents 1, they can get very confused. So here's an example. Sean's family made 3 trays of brownies. Sean ate 2 from 1 batch and 1 from the 3rd batch. So there's the picture. Okay. So what are the different ways, just based on this idea, that people could say how much, we'll just be very generic, did Sean eat? And that's the problem if we just say how much what? Okay. So if the person answered 3, well, they're thinking of this as a unit. Okay. And we might call that a brownie. So I would call, there's a tray of brownies, it's cut into 6 brownies, he had 3 brownies. Okay. A person can look at this and say he ate 3 6. So then the question is 3 6 what? Well, that person would be thinking of 1 tray of brownies as being the unit, and Sean ate 3 6 of a tray. And then lastly, we have 3/18. Well, that person could be thinking of all the brownies that were made. So there were 18 brownies made. I'm not going to draw this, but look at all 3 together. And they ate 3 brownies out of the total of 18 brownies. Now notice, all of those are completely reasonable and make sense based on the unit the people were thinking of. So if we don't talk about our units or reference our units in the question, a student can answer any one of these. They could be wrong based on what we were thinking of the unit as, and they'll have no idea why, and they'll just be confused. Because notice, their answer makes sense in the context of the unit they're using. Okay? So very important to talk about units and make sure you start to use the unit language. I'm guilty of it sometimes too. We have some general formalities that we tend to use just from our experiences being teachers of what we think a unit is. Lots of times we think of it as 1 of something, okay? But notice, a unit doesn't have to be 1. These 3 trays and these 18 brownies can be the unit and be equal to 1. Okay. So we'll end this video, and next we'll start on unit fractions.